Hi, Algebra 1. We are ready to continue moving through our Chapter 7 work today. And so this video is all about Chapter 7, Section 3, 7.3. So you should have your books out in front of you, open to page 426. You should also either print out the notes or have paper and pencil to take notes as I go through this. Even if you choose not to print out the notes, you should have opened that handout because there's a lot of important information I'm including in those handouts that you should at least read. So make sure you've done that. Okay, we're ready to move forward today, and today's video should be a little bit shorter than the other ones. I'm just going to tackle one property today. And we are going to be multiplying powers with the same base. So if you look at my board, I'm showing you an example problem here, and it's in your book, and it's in your notes too. If I were to multiply 3 to the 4th power times 3 squared, this is the situation we're talking about. Because if you remember from our vocabulary last week, my 3 is my base. And this property only works if you're dealing with numbers of the same base. So both of these are 3's, so this property applies. Whenever I write this out, 3 to the 4th is 3 times 3 times 3 times 3. 3 squared is 3 times 3. Now, if I were to write them out like that, I could see how many 3's I'm actually multiplying together. It would give me 6. So my answer for this problem would be 3 to the 6th. My simplified version of this problem is 3 to the 6th. If I wrote it out, I see that it adds up to 6. Which sets the stage for today's property. Our property states that to multiply powers with the same base, you add the exponents. And that's shown here. A to the m times a to the n is the same as a to the m plus n. That means we are adding the powers together. 2 examples in your book and in your notes. 4 cubed times 4 to the 5th. I recognize they both have the same base of 4, so I add the exponents, 4 to the 8th. B to the 7th times b to the negative 4th, same base of b, I add them together. Now be careful here, even if you have negative exponents, the property applies. 7 plus negative 4 gives me b to the 3rd power. Okay, so we're going to move on to problem 1. Following along in your books or in my note handout. I have them already written here. My first problem is 12 to the 4th times 12 cubed. It's very simple. We're starting out very basic for this property. It looks just like the examples we just did. I notice that my base is 12, so this property applies. I'm going to look at my exponents, 4 and 3, and I'm going to add them together. So the simplified version of this problem is 12 to the 7th. It's okay that there's people walking around in my house. We all still have to live together. My second example, if I have negative 5 to the negative 2nd power being multiplied by negative 5 to the 7th power, again, recognizing that my base is what is being raised to the power, and it's the same here, I would add my exponents together. Even if I have a negative exponent, I'm still going to add them. So negative 2 plus 7 gives me an answer of negative 5 to the 5th power, is the simplified version of that. Okay, at this point, you need to pause the video and try the 3 practice problems in the note handout, or they're the got it problems under problem 1. So go ahead and pause that now, and then come back when you're done. Okay, if you are watching now, you have finished those practice problems. Let's take just a minute, actually, probably will all we need to go over these 3 problems. These are very basic problems again. My first one, 8 cubed times 8 to the 6th. My base does not change, but my power does. 3 plus 6 is 9, so it's 8 to the 9th power. Example number 2, 0.5. Remember, it doesn't matter what my base is. It can be a fraction, it can be a decimal, it can be a negative number. It doesn't matter. As long as it's the same in the problem, then I can apply this property. So if I do that, I know my base is not going to change. let me move that up here, 0.5, then I'm going to add my exponents. -3 plus -11, or 8, gives me -11. So my simplified answer to this problem is 0.5 to the -11th power. But something that I need to get very comfortable with here is if I am, actually, you know what? I am going to double check to see what the book tells you here, because I might override the book here. Let's see. Okay, they allow you in this section to leave that negative exponent. But I want you to get into the habit of anytime you have a negative exponent, you clean that up. Consider your answer not simplified until all the negative exponents are dealt with. So we need to combine today's lesson with what we learned last week. If I see that I have a negative exponent, I need to turn that into a fraction, bump my base to the basement or the denominator, and make it a positive 11. This would be the correct simplified answer for that problem. Okay, the last one. This one is no different in the skill that we're going to use. Don't be intimidated by the fact that there are 3 numbers being multiplied together in this problem. I have 9 times 9 times 9. So I have 3 bases that are all the same. So that means my base and my answer is still going to remain a 9. Then I'm going to add the exponents. It doesn't matter if I had 30 different exponents here, I'd still add them. So -3 plus 2 plus 6 gives me 9 to the 5th power as my answer here. Okay, I'm going to take a second now and clear my board, and so we can move into problem number 2. And then that's all we're going to cover for today. Problem 2 is going to be examples that take this one step farther, where we have a little bit more going on in the problem. So hang tight with me just a minute while I write these problems out. Okay, I'm going to give us lots of room. Something you also need to know about problem number 2, letter B, this second one. When I wrote out the note handout, oh, you can hear the wind blowing like crazy here. When I wrote the note handout, I changed this a little bit, and so this problem is slightly different from the one that's in your book, but that's okay. The concept is still the same. Okay, so our first 2 examples. Hey, what happens here when we add in a lot of different components to these problems? You'll notice instead of just having 2 bases that are exactly the same and applying the property, that we need to make it a little bit more difficult and be comfortable when we have numbers and variables. So whenever I have this problem, I take each chunk and deal with it together. So my first step is going to be to deal with my numbers. I have 4z to the 5th being multiplied by 9z to the -12th. Well, the first thing I'm going to attack is the numbers. 4 and 9, they're both regular old numbers. So I'm going to do that math. 4 times 9 gives me 36. So I dealt with that. My next step is to look at my variables. Now in this case, I have a z and a z. They're both the same base, so I can apply my property that we just learned. When I'm multiplying bases with powers, same base, I add the exponents. So my z is still going to remain in my answer, but my exponent will now be 5 plus -12, which is -7. Remember what I just said though. If we have a negative exponent, we're not done. I now need to bring in what I learned last week about negative exponents and convert that to be 36 over z to the 7th. I took this z to the -7th, and I know that a negative exponent means I bump it to the denominator. But remember that this -7 only refers to this z, only to what is immediately in front of it. So my 36 stays just where it is, but my z moves to the denominator. Okay, look at the next one. And then again, I said this is slightly off than what's in the book. That's okay. Just pay attention to this problem and solve it for what we see here. in this case, again, now I have three different terms. 2a times 9m times 3a squared. My first thing I'm going to do, just like I did in this problem, is to find all my numbers. So I say a 2, a 9, and a 3. And the operation is multiplication, so I'm going to go ahead and multiply that, and that gives me 54. Then I'm going to look at my variables, and I'm going to notice right away that I have an A, an M, so they're not the same. I cannot apply my power rule to this one, to that at all, but only my A's will work right now. So I have an A times A squared. It's very important that you pay attention here and remember that what power do we have with this A? What exponent does that have? Don't say 0, because there's not a 0 there. And don't say nothing, because there is something there. Remember, it's my assumed 1. A is a to the first power. So that is helpful to remember here, because now I'm adding 1 plus 2, and I'm going to get a cubed in my simplified answer. That leaves me with my last part, my M. I still need to deal with it. I don't just forget it. I don't ignore it. It stays in my problem, but there's no other M's to multiply it with. So it's just going to stay the same. It's going to remain M. That power is 1. But remember, I don't need to write that when I'm writing my answer. So I took my numbers, got 54. My A's multiply together to get me A cubed, and my M stays the same. Okay, now I need you to pause the video, turn to the there's 4 actually in a note handout that I want you to look at. 3 that you should be able to do. The 4th one's a challenge one to make sure you're kind of understanding the theory behind this. So pause this video, try those on your own, and then restart it when you're ready to go over it. And while you guys do that, I'm going to clear my board and get our new problems on here. I like to get you to use all the different possible letters. Thank you for your patience. Got one more to do. Okay, we'll take these one at a time. These are the 4 practice problems you just did, and let's go over the answers. Okay, remember, if I have a lot of different components here, I start with my numbers. 5 times 3 is 15. Great. I can even start crossing out things that I've dealt with. That might help you, at least at these beginning stages, make sure you're not losing track of anything. And then if I look at all of the remaining variables, they're all x's. So they are all the same base. So I just take all 3 exponents and add them together. But notice this x doesn't have an exponent written in. It does have an exponent, it's just the assumed 1. Don't forget that. So now I have 4 plus 9 plus 1 gives me 15 to the x to the 14th power. 15x to the 14th power. Okay, let's look at the next one. Again, find your numbers first. I have -4, 7, and 2. And if I multiply that together, I get a -56. This is where your calculator will come in handy just to confirm you're getting the correct answers. And don't forget all of the things we've learned about with negative numbers. An even amount of negative numbers multiplied together gives me a positive number. An odd number, like in this case, gives me a negative answer. Okay, I dealt with my numbers. I'm going to cross those out. The next base I want to deal with is my C's. C, I'm going to write in that 1, and C to the -2. 1 plus -2 gives me C to the -1 power. Cross that out. and then I see my d squared. There's no other d's, so it's going to remain a d squared. Now remember, oh guys, look what I did, just like in the classroom. In the problem, this is a 3. Meaning 3 plus negative 2 is 1, and I don't need to include that one. Sorry, gotta make you feel comfortable like in the classroom where I am bound to make mistakes all the time. Okay, look at the next one. We have j squared times k to the negative second times 12j. It's okay. I don't need to be intimidated. I take it piece by piece. Find my numbers. I only have one there that matters. This is 1j squared. This is 1k to the negative second. So 1 times 1 times 12. I can just jump right to the 12. I'm going to cross that out once I've dealt with it. My j's are next. J squared times j to the first gives me j cubed. I'm going to cross it out because I've dealt with it. Then my k to the negative second is next. Nothing else to combine it with. But what do you notice about that? A negative exponent. I cannot leave that there, so I need to bump that to the denominator. It is not simplified until all of my exponents are positive. Okay, the last one is just a challenge problem. Just making sure you understand the property at work here. X to the A times X to the B times X to the C. You might be thinking, Mrs. Agate, there are no numbers there. What can I do with that? Well, we can still simplify it following this property. My base is X. That's not going to change. And so what would I do? I would add all 3 parts. So my answer to this would simplified be X to the A plus B plus C. That is correct. Okay, that concludes our lesson on 7-3. On the note handout, you'll see the suggested problems listed there from your book, page 429, 9 through 27 odd, 37 through 43 odd. I'm saying those fast because they're on RunWeb and they're on the note handout. Remember, once you've watched this video and you've tried these practice problems and you're feeling comfortable with this, then you head to Khan Academy where you will see my assignment there. It's called Multiply Powers. One thing that I want to make sure you are understanding is that the quizzes on Khan Academy are very basic. And so they are not covering everything that you will be responsible for moving forward. So make sure you are still doing the suggested problems in the book, especially the higher numbered ones. We will have a quiz on Thursday covering 7-1 through tomorrow's lesson on the first half of 7-4. Again, all of this is on RunWeb. All of this has been emailed to you, but you need to know that my questions on the quiz may be harder than Khan Academy's. So you need to be doing all of your work. Okay, I will explain all the details though on the quiz or for the quiz during our Zoom session on Tuesday. So if you're feeling panicky, like, how are we gonna do this? Calm down. It's not going to be due until Thursday, and I'm gonna cover it in Zoom. Okay, that ends our lesson on 7-3, and I will see you next time.